So today we're going to talk about factoring dots, DOTS, which stands for the difference of two squares. So you'll notice this is the form of what we're going to see for our dots pattern. When I have two terms, it's only a difference and each term is a perfect square. We can use this special pattern. Okay? So again, this only works if we have the difference. It is a binomial, so it can't be the third term or a trinomial, and both terms have to be perfect squares. Okay, so here's how this works. So if you see that pattern, or if you see an a squared minus b squared, you're going to set up the two binomials. And basically what that means is we're doing our double bubble. You're setting up your parentheses. One binomial is going to be plus. The other binomial is going to be minus. This is how we end up canceling the middle term. So even though we're multiplying two binomials together, the middle terms will cancel because one of them is positive, one of them is negative, so they end up canceling out the middle term. We'll see what that looks like in a minute. So what we're going to do is put the square root of the first term in the first spots and the square root of the second term in the second spot. So they go into their specific areas. And again, we always check, especially when we're doing a quicker special pattern, we want to just make sure it works and we didn't do something wrong. So here are a few examples. So if I am looking at x squared minus 25, well, does it satisfy the factors? It is a difference. Yes. It is a binomial. There's only two terms. Yes. Is each term a perfect square? Yes. So I look at my steps. It says set up the double bubble. Take the square root. I'm sorry. We'll go right the way it says. The second step says one is positive, one is negative, or one is minus. The next step says to take the square root of the term, so the square root of x squared is x, the square root of 25 is 5, and again, check it. Well, if I do x times x, I get x squared. If I do the 5 times the negative 5, I get negative 25. But then if I focus on the middle terms, I get 5x and a minus 5x. And that's where they cancel out, which gives me the x squared minus 25. So on to the second one. It is a binomial. It is a difference. That tells me that one is positive, one is negative. This time I see the square root of 64 first. So I'm going to put the square root of 64 first. And then the y squareds, when I take the square root, is going to go in the back. And again, through my check, the 8y and the negative 8y's cancel. The last one we just got to think about. So is it a difference? Yes. Is it a binomial? Yes. Is each term perfect square? Yes. If I think about that, 4 is a perfect square. Z squared is a perfect square. So the entire 4z squared is a perfect square. So I would have 2z in the front. One is adding, one is subtracting. And if I look at the perfect square of a 1, that is 1 times 1. So I would get 2z minus 1 and 2z plus 1. So pause the video, try those next three, and then just come back and we can make sure that we have the same answers. So here they are. How'd you do? Well, when I look at those, again, I am going to get, the first one is going to give us x plus 6 and x minus 6. The second one is going to be 10 plus m and 10 minus m. And the last one is 3n plus 4 times 3n minus 4. And again, the one thing I do think you have to keep in mind is you have to keep checking these. So again, if I was to use my FOIL method, here's the x times x, which is x squared. Here is 6 times x, which is 6x. Here is 6 times negative 6, which is negative 6x. Negative 6x and positive 6x cancel. And then the 6 times the negative 6 is my negative 36. It's important that you are checking to make sure that you do have the correct factored binomials. So lastly, we want to go down to here to another real-life situation. See what this looks like. We have a bird who picks up a golf ball off a golf course someplace along the way and then drops it while flying. The function represents the height y in feet of the golf ball t seconds after its drop. The ball hits the top of a 32-foot tall pine tree. How many seconds, so we're looking for seconds, does the ball hit the tree? So again, I look down here to the function that I have to work with. It's right down here. 81 minus 16t squared. Again, the negative 16t squared is showing us the gravity pull coming back down to Earth. This 81 here, now we don't see this in our standard form right now, but if I was to rewrite this as negative 16t squared plus 81, write that a little bit neater. This negative 16t is what we've referred to as the gravity pull. This plus 81, there's no t's next to this. This plus 81 is referring to the height that it is being dropped. This means that it was 81 feet up in the air when the bird dropped it. So while this question is not asking that, that is something that we could actually determine if somebody said, well, what was the height of the bird when it dropped it? It was 81 feet. Not important on this one, but is more information that we can come up with. Okay? So, to be able to solve this one, we have a couple of things. What do we need to know? Well, we said we need to know seconds. Seconds is t, so we have to solve for t. We have some information here about when does the ball hit the tree. Well, we know y is our height, and the tree we know is 2 feet tall. So I'm going to plug in 32 for the y value and find out where is that hitting. Now I'm going to leave this 81 minus 16t squared. You could have rewritten it like I did underneath and done it. I only did that just to talk to you about the height of the bird. So we're going to leave it the way it is right now. So remember, to be able to factor this or to solve that t and get it by itself, what we have to do is get the left-hand side right now equaling a 0. I'm going to line up like terms when I subtract the 32 from both sides. I'm going to get 0 equals 49 minus 16t squared. So now I want to think, well, this is my dots. This is a difference of two perfect squares. It's a binomial on the left-hand side, on the right-hand side, and they're both perfect squares, and it's a difference. So here's where I can set up my double bubble. I know one is plus, one is minus. The square root of 49 is 7. The square root of 16t squared is 4t. So I've now factored, and I can now use my zero product property to set those two expressions equaling 0. So 7 plus 4t equals 0, and 7 minus 4t equals 0. Then I just use my regular SADMAP steps to get 4t equals negative 7. Divide by 4. T equals negative 7/4. I would subtract 7. Negative 4t equals negative 7. When I divide by negative 4, t equals positive 7/4. So then I want to look at my answer, because this is the solutions, these are the solutions to this polynomial that were factored. However, the question is asking for how many seconds until the ball hits the tree. Well, unless we're going backwards in time, it doesn't really make any sense to say that something is hitting at negative 7/4 second. So again, this is a solution to the equation, but we're going to throw it out because it's kind of what we call that extraneous solution where it doesn't really make any sense to this problem. So that means, though, I am going to grab this solution over here, and I'm going to say that the ball hits in 1 3/4 seconds. I know we've always talked about only leaving things as improper fractions, but in this situation, I don't think you would probably tell your friend that the ball hit in 7/4 seconds, so we probably would want to turn this one into 1.34 seconds. So dots is certainly something that will help you go a little bit faster if you recognize it, so that you can set up your double bubble a little bit quicker and get to your solutions a little bit faster.